Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to identify an unknown metal based on the information you're given for a reaction that it undergoes. So let's get into this. So here we have a metal M that forms the sulfate M2SO43, and we're given that 0.738 gram sample of this sulfate, this M2SO43, is converted to 1.511 grams of barium sulfate, and they want to know what is the identity of M. So right away, when they're asking for the identity of M is some metal, right? Some element on the periodic table. So how do we identify elements on the periodic table? Well, there's a couple of ways. You identify it by its atomic number, which is the number of protons, but that's not going to help us in this problem. The other way is to identify it by its molar mass, its atomic mass or atomic weight or weighted average. That's given to us, and that each element has a particular average atomic mass, so which is the same as its molar mass. So if we could find the molar mass of this metal, this unknown metal, then we could figure out from the periodic table what the element is. Okay, so how do we find molar mass, or what is molar mass? How do we calculate it? So let's remind ourselves that molar mass is moles. Oops, nope, not moles. Sorry, grams. Oops, I keep making a mistake. This should be equals. Molar mass is equal to excuse me, grams per mole. Grams divided by moles. So if I could figure out the grams of my mystery metal and I could figure out the moles of my mystery metal, then I would just divide those two, and then that would give me the molar mass of the mystery metal, and I would look on the periodic table for that. So how do we find out grams and moles of our mystery metal? Well, let's work on grams first. Well, they're giving us 0.738 grams of this mystery sulfate here. Okay, and then they tell us that this amount of grams is going to provide or produce 1.51 grams of the barium sulfate. Well, if all of the sample, this 0.738 sample, if all of that sample is converted into barium sulfate, meaning if all that sulfate that's in the mystery sulfate, the mystery metal, M2SO43, if that gets all converted over to barium sulfate, then we could find the mass of the barium sulfate. I'm sorry, the mass of the sulfate that's contained in the barium sulfate, because all of that came supposedly from this metal sulfate that we have to start with. And if we could find the mass of the sulfate, all we have to do is subtract that from our original sample, 0.738, and whatever's left has to be due to the mass of the metal itself. So that would give us the top part. Okay, let's do that. So we're going to take 1.511 grams of the barium sulfate over 1. And then we're going to convert that to moles. So we got to look up and calculate the molar mass of barium sulfate. And when you do that, you get 233,386. So 233 point, what's that? 386 grams, and that's of the barium sulfate. And then on top we have 1 mole of the barium sulfate. So grams cancels out. And then we can convert from moles of barium sulfate to moles of the sulfate. And we see here that it's a 1-to-1 ratio. For every 1 mole of barium sulfate we have 1 mole of sulfate. So we can use that mole ratio. So on the bottom we put 1 mole barium sulfate. On the top we have 1 mole of sulfate. And we get that mole ratio directly from the formula. So the moles of barium sulfate cancel out. Now we're left with moles of sulfate. And so now we can convert this to grams of sulfate. So one last step, we need the molar mass of sulfate. And so when you calculate that, you get 96,056. So 96.056 grams of the sulfate, and on the bottom is going to be 1 mole of sulfate. So moles of sulfate cancel out. I'm left with grams of sulfate. So now all I need to do is multiply by everything on the top, divide by everything on the bottom, and I get my answer. And when I calculate that out, I get 0.62189. 0.62189 grams of sulfate. So that's the amount of sulfate in the barium sulfate that was formed. And supposedly, that's also the same amount of sulfate that was in the original sulfate with the mystery metal. So we can subtract this from the original amount of the sample here. So we can just subtract this from this, and the leftover mass has to be due to the metal alone. Now, before we go on to that part, we should specify how many sig figs we have in our answer. And remember, the rule is when you multiply and divide, the number of sig figs that you have in your answer should be the same as the least number of sig figs, or the same number of sig figs as the measurement with the least number of sig figs in it. That was a pretty convoluted way of saying it. Let me say that again. So the number of sig figs in your answer has to be equal to the same number of sig figs in the measurement with the least number of sig figs. Hopefully that sounded better. So here I have 4 sig figs. Here I have 6. This is exact. And here I have 5. So the least number is 4. So I should have 1, 2, 3, 4. So my 8 here is the last significant figure, but I'm going to keep 1 digit. Always keep 1 digit in your measurement, in your answer, if you're going to go forward and use this in further calculations, which I'm going to do. So I'm going to subtract this now from the original amount of the sample, not from this amount here. So, sorry, I keep pointing at this one. This is the original sample of this. Oh, yeah, no, I was right the first time. So then this amount of sulfate supposedly came from this amount of the mystery metal. So if I subtract this from this, I should get the mass of the metal that was left over. And that's going to be, yep, let me write that out. So I have 0.738 grams minus 0.6218 grams of the sulfate. So this is the mass of the M2SO43. This is the mass of the sulfate in this amount of sample. And so when I subtract that out, I should have just the mass of the metal. and I get 0.11611, 0.11611. Let me double check that. Yes, this is grams of mystery metal. And we know that the metal is going to have a +3 charge on it. Why do we know that it's going to have a +3 charge on it? Because of the formula. So here I have two metal atoms that's supposed to balance out the sulfate atoms, or sulfate molecules, or ions, I should say. Each sulfate ion has a -2 charge, and I have 6 of those. So if I have a -6 charge total, then I have to have a +6 charge to balance the total negative charge of 6. So remember, all ionic compounds have to be neutral. So if I have a total of a -6 charge, I need a total of a +6 charge for the metal. I have two metals, so that +6 has to be divided evenly among the two metals, and that's 3 apiece. So I know that this has a +3 charge. Now, if you know your periodic table and the charges, this could be a group 3 metal, a group 3A metal, right? Maybe not, though. It could also be a transition metal that has a +3 charge, right? And transition metals can have multiple charges. So there are options. But I just want to note that one possibility is that this is a group 3 metal. Okay, let's find out if that's true. Okay, so here's the mass. So we have mass in grams. So now all we need to do is find the moles. So a couple of ways you could do this. You could start with the grams of sulfate that you have, and you could use that to convert that to moles of the mystery metal, since we know the ratio of the sulfate to the metal, right? So moles, we got 3 moles of sulfate for every 2 moles of metal. We could use that to convert to moles. So you could start with this, but maybe you got this wrong. Maybe you're off by a little bit. So you might start with the given amount and start with that, because we know that this is given. This has to be true. So we could start with this and get our answer from there. But either one is fine. I'm going to start with this. So if we start with this, we're going to convert this amount of barium sulfate to moles of the metal that the sulfate came from. Okay, so we have 1.511 grams of the barium sulfate. And again, we're going to multiply that by the molar mass to convert that to moles. So we're going to have 233.386 grams barium sulfate and 1 mole of barium sulfate. So grams cancels out. We're going to use our mole ratio to get to moles of sulfate. So 1 mole of the barium sulfate is equal to 1 mole of the sulfate. Because of the formula, it's a 1-to-1. So there's moles of barium sulfate cancel out. Now I have moles of sulfate. Now I can go to the formula here and use that as a mole ratio. So here it's 3 moles of sulfate to 2 moles of the metal, the mystery metal. So now all I need to do is use that as a mole ratio. So I have moles of sulfate on the top, so I'm going to put 3 moles on the bottom because the subscript here says 3. So I'm going to have 3 moles of SO4, and I have a 2 subscript there. That's 2 moles of the metal. So 2 moles of this mystery metal that has a 3+ charge. moles of SO42. That's should have a 2 minus charge on there. Sorry about that. I forgot it up here too. Don't forget your charges there too. And so now moles of the SO42 minus is going to cancel out. And now I have moles of the metal, the mystery metal. So now all I need to do is, again, multiply by everything on the top, divide by everything on the bottom, and I get my answer. And so again, when we calculate that out, you're going to get 0.0043 0.0043 1617 moles of the mystery metal with a 3 plus charge. Okay, so let's look at sig figs. So let's go back here. I forgot to come back here for the sig figs. So remember that for the measurement here, when we did the calculation for the grams of sulfate, we indicated here that the 8 is the last sig fig for this answer. And so we're underlining that to remind us. Now here, when you're subtracting, so I'm subtracting the mass of the sulfate from the total mass of the compound of the M2SO43. And the rule here is when you subtract, your answer should have the same number of decimal places as the least number of decimal places in the measurements you are subtracting or adding. So in this case, I have 3 decimal places. Here I have 4. 3 is less than 4, so I can only keep the number up to 3 decimal places. So 1, 2, 3. I keep an extra digit or 2 because I got to use this in the next calculation. But I underline it to remind myself how many sig figs I'm allowed to keep for this answer. Now I have the moles of my mystery metal. Again, sig figs, when you're multiplying and dividing, the rule is that your answer should have the same number of sig figs as the measurement that with the least number of sig figs. So again, this has 4, 6 here. This is exact. This is exact. So again, 4 is the least number. So these zeros in front are not significant. They're just placeholders. So I count 1, 2, 3, 4. So the 6 is my last significant figure. I keep 1 or 2 places because I'm going to be using this in the next calculation. And I don't want a rounding error. So now look, I have moles of my mystery metal. I have the mass of my mystery metal. Now all I need to do is divide grams by moles and I get my molar mass. So let's go ahead and do that. So I'm going to take 0.11611 grams divided by 0.00431617. Notice I've underlined the 6 here and the 6 there to remind myself about what the sig figs are for these measurements. And when I divide these, I get 2690. And so since I have 3 sig figs here and 4 here, since I'm dividing, the rule is that my answer should have the same number of sig figs as the least number of sig figs in my measurements. This has 3, this has 4, so I should keep 3. So I'm going to get rid of that. And this is 26.9 grams per mole. And so I look on my periodic table for that number, and behold, aluminum is the metal that has that molar mass. So indeed, this is a group 3 metal, right? Because aluminum is group 3, it has a 3 plus charge on it normally. So that is the answer. That's how you get this problem. I hope this was helpful. If you enjoyed this video, if this helped you in any way, then please like the video, share the video, hit the like button. Also, make sure you subscribe to my channel. Hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, put that down below. If you have a topic you would like me to cover, put that down below. I would love to do that for you. Thanks for joining me and have a great day.